Hello friends! In my last video I introduced this LC575 Mystic motherboard as an upgrade for my Color Classic. And in today's video we're going to recap it with Panasonic OS-CON capacitors. Unlike the stock capacitors, OS-CON capacitors have a solid electrolyte that can never leak. And unlike solid tantalum capacitors that are often used to recap these boards, OS-CON capacitors do not catch fire when hit with a voltage spike and have lower ESR, which can be a benefit in this particular application. Another potential benefit for you purists out there is that OS-CON looks stock, except they're a little bit smaller. And here is my soldering setup for today. Over here on the left I have my soldering wheels, two different types, one thin, one thick. Then in the middle here I have my Hakko 937, this model is no longer sold, set to 350 degrees Celsius. Then down here I have some Flux, AMTECH LC575. Here in Japan, they only sell the fake Chinese stuff, so I had a family member ship the genuine made in USA product over to me. I've never used this before, so we'll see how it goes today. And then over here, I have my Hakko 950 50-watt tweezer set to make desoldering SMD components a bit easier. I'll start by putting some flux on these two 100 microfarad capacitors to desolder them first. Now, to make everything a bit easier to desolder, I'm actually adding solder, a little bit of solder, to the inside of each of these tips. So, here we go. And just to show you, you don't need to worry because it's marked plus, which means ground is on the opposite side, so you'll always know how to put them back in. And even the silk screen, you can see the little curve here on this corner and here, but it's more squared off on the ground side. Plus you have my video, so you will always get the polarity correct so long as you follow this information. Now I connected my soldering iron so that I can use my copper braid here to kind of clean up the pads a little bit. If you find your braid is sticking, you can just add some more flux. Now before I solder in replacements, I just want to show you what the ESR of the stock capacitor is. You can see it's just about 93, 94 microfarad, and the ESR is, depending on how hard I press on it, about 6.6 ohms it's showing right now. And the other capacitor I removed is 95 microfarad, 4.7 ohms. And the OS-CON replacement is showing 99 microfarad at 200 milliohm. And by the way, this is being all done at 120 hertz, which is important when you measure ESR. You need to know what the frequency is. Before I desolder the 47s, I just let my tweezers cool down so they're cool to the touch now. Just to show you, you might be wondering, well, what about this connector? And yes, you can see it comes precariously close, but technically it doesn't touch unless you were to rock it this way, and now it touches. So it's most likely in your best interest to put some heat-proof tape over the connector, just in case you make a mistake. Unfortunately, I don't have any of that tape myself, but those of you in North America can get it for a pretty good price, and it will protect your connectors if you use tweezers like I am. Some of you will try to do two soldering irons, but it's the same precarious situation, right? You don't want to melt your connector over here. And here are the two 47s near our audio jack. These two are near the RAM SIM socket. to be careful. Again, you can put some tape here to protect it. And this guy near the VRAM is in a very precarious place, so again, you might want to put some tape here on your socket to protect it. And the two guys near the CPU. And now for the final three guys. Now for some pad cleaning. Now that all the capacitors have been removed, I'm going to clean up all of the flux and any possible spilled fluid electrolyte that I couldn't see maybe, but maybe it's on the board, using my 100% ISO alcohol here, which I put a little bit here into the spray bottle to make it more convenient to get onto the motherboard, and I'm going to be scrubbing it down with my toothbrush and then wiping off any excess with some tissues. Okay, now that the board is clean, I think we should start with the 100 microfarad capacitors starting at C4. So we'll add a little bit of flux on here. And of course we want to make sure we get our polarity correct. The marked side on the left is ground. Now if I take my meter connected to continuity mode, whenever the two probes are connected it beeps. So we want to make sure that we're not shorting together the right and left sides. It beeps once, that's fine, but see it's not giving a continuous beep, which means the plus and minus are not shorted together. And that's important because if you shift the capacitor too much to the left or to the right, it could short. Now we'll do C1. Now we'll do our continuity check across. One beep is fine. That's ground, see? So that's fine. And now we can start with our 47 microfarads, noting that here at C5 and C2, plus is now going to be on the left for both of them. So we need to have the marking on the right. All soldered in, and now we need to clean off the flux. Now I'll take my blower and just blow on it, because there's some obviously under the chips. It is alcohol, 100%, so it does dry fast, but I want to get as much of it out as possible. See, a lot of it is there. One thing I noticed after my alcohol clean was this exposed copper. It seems to have been covered with UV solder mask. I'm also seeing it near the VRAM socket. It seemed like it must have been scratched. This part of the UV solder mask under this capacitor is still intact. And then over here we can see that the scratch extended to this part and it's a little bit exposed. So I will apply a little bit of my own solder mask and cure it with this UV flashlight. It can take a while, even with this 10-watt UV light. Of course, I put a little bit too much on, and that's partly why. So far, I've been applying the light for about 5 minutes. We'll try a little bit less on this one. And don't leave the UV light on too long like I did, or you'll discolor the board. Live and learn. For example, masking off the area as K Koba shows here is the more intelligent way to do it. Now with the memory and VRAM back in, it's time to give it a test. I've got the power switch switched on in the back, and all I need to do is push the power key. Hey, we got a bong! That's basically proving that our motherboard was recapped without problem. No smoke coming out, no popping. Got the hard drive spinning up. And it's booting up just fine. I've been running benchmarks for a number of hours to prove that it is indeed stable. The recap was definitely a success, and no, it does not affect performance in the least bit. You can see my previous benchmarks and current benchmarks are pretty much exactly the same, of course. So in closing, I can wholeheartedly recommend the Panasonic OS-CON capacitors. Just to repeat, these capacitors have extremely low ESR. Not quite as low as ceramics, but very, very close. Ceramics are about as low as you can go in terms of ESR for capacitors. But they're better than the ceramics because ceramic capacitors have a bias voltage issue. All ceramics except for MPO and COG. But those are specialty capacitors that only come in very tiny sizes like picofarads and nanofarads. All other capacitors, X7Rs and all that, they have an issue whereby the higher the bias voltage you apply to them, the lower the capacitance goes. That's right. The capacitance actually drops in accordance with the voltage. And that's really a big issue. So if you want to use a ceramic capacitor on a 5-volt line, you'd really need to go with a 50-volt rated capacitor in order to ensure that your capacitance is going to be about what the general rating is. And on a OS-CON capacitor or tantalum capacitor or the other capacitor types, you don't have that issue. There are a lot of other issues with ceramic capacitors as well. They just, you know, for sizes like this, 100 microfarads, you're just not going to use a ceramic capacitor for that. The OS-CONs are really ideal. You could also go with tantalum, and I see that most of you who actually recap these boards use tantalum, and you tend to use solid tantalum too. There's nothing necessarily wrong with that, but you do have to watch out for the voltage rating. And I would highly recommend that you watch my video on how to pick out capacitors, because I go into more detail on that. But basically, in terms of ESR, you have the fluid-filled aluminum electrolytic capacitors, which have fairly high ESR. And then the next level down would be solid tantalum capacitors. Then the next level down would be polymer tantalum capacitors. And then even lower than that are the OS-CONs that we use today. And then, of course, below that are ceramics. So using the lower ESR capacitors on this particular board are great, because these capacitors used here are not a part of a switching power supply. These are bypass capacitors. And what that means is they're basically holding up the voltage rail. They're making sure there's no voltage sags when the CPU suddenly wants to draw more power, or some power memory chip needs more power. Usually what you do, you have is a cheap fluid-filled aluminum electrolytic capacitor that's 10 microfarad, 47 microfarad, 100 microfarad, and then you have a 0.1 microfarad ceramic capacitor with very low ESR, and then that ceramic capacitor is very close to, say, the 5-volt line of a microprocessor, and whenever that microprocessor suddenly needs power, it can supply that power first because of its very low ESR. And there's kind of an overlap between the slower aluminum electrolytic capacitor and the ceramic capacitor, such that by the time this guy is almost drained, this guy will overcome his ESR and be able to supply his current too. But what we've done is we've taken away all of those high ESR aluminum electrolytic capacitors, and we've replaced them with much lower ESR versions. And that's going to be great, because on this board I'm going to swap out the CPU with a full FPU version. That means it's going to draw more power, and I'm going to overclock it as well beyond 40 megahertz, and that also will draw more power. So you need a robust power supply, obviously, to do this, but this power supply analog board has already been recapped, so that's not a problem. The main issue is, can you supply the necessary current on the board in time? And by having lower ESR capacitors, the answer is yes. So they will satisfy the need for a more power-hungry CPU better than if we were to have just replaced them with a higher ESR version. Even better than tantalums. Now, I'm not criticizing those of you who have used tantalums. Tantalums, especially the polymer type, are just fine. It's just that OS-CON are even better. And so with this video, you can proceed to use them on the Mystic LC575 motherboard without problem. Next, I'd like to talk a little bit about the Flux. I had introduced it, and I said the AMTECH 559 Flux, this is the first time I've used it. And until now, I've been using MG Chemicals Flux in this particular syringe here. And this is sold, the MG Chemicals is sold on Mauser. And for some reason, Mauser doesn't sell the AMTECH. But I've heard a lot about the AMTECH. A lot of people were just raving about it. And I said, well, I want to see what all the fuss is about. Is it really good or not? And, you know, it's not bad. It's on par with my MG Chemicals, which is a pretty good flux. You can see this one is fairly, you know, just a little bit darker in color, in the gold color, than this one. And that's because the MG Chemicals has a little bit more rosin in it. And because of that extra rosin content, it takes just a tad bit longer to burn off than this one, which is a good thing. You don't want your flux to burn off right away. And but overall, it's very comparable. The big disadvantage to the AMTECH, though, is the design of this plunger. And the reason why, right now I have the stopper that's applied to this. And whenever you push on the plunger, this part is the plunger, whenever you push on the plunger, it will, of course, push out flux that you need on your board. But then you release and you put it down. The problem is the flux keeps coming out for a little while. And the reason why is because even though you released the little slider inside, it doesn't push back on its own. It's still applying pressure to that flux inside, and until that pressure is alleviated, it comes out. Now, I don't have to worry about that with my MG Chemicals flux. It has the same problem, but all I have to do is just pull back on the plunger, and it just sucks in the flux, which is great. I mean, this is a well thought out syringe. But this one, whenever you try to pull it back, watch what happens. it pulls right out. And on the MG chemicals, I don't even know how to pull it out. It seems to be built into it, which is the way it should be. So there's no way that you can alleviate the pressure by pulling it back. And I posted about this on the Tinker Different forum, and a lot of people very kindly offered me a reply. But basically, all of the solutions cost me time and money. For example, to print up something, a 3D printed new plunger, or to change syringes by pushing out all this flux into a better syringe. I can understand why people would want to do that, but I don't need to do that at all if I buy the MG Chemicals Flux, because it has a better plunger. I mean, just out of the box, it works. So I'm kind of disappointed, not because the Flux is bad, but because the overall experience of using Flux is really tied to the container that it comes in. And I'm not really satisfied with this at all. So if anyone who works for AMTECH is watching this, definitely you want to improve your product in that regard. And of course, I'm still going to continue using this Flux until it's gone. But once it's gone, will I buy any more? Well, probably not, unless they improve the plunger, because this MG Chemicals Flux really does the job, and the plunger works great. Plus, the needle on the MG Chemicals, it's longer than the AMTECH, and the diameter of the hole is wider, so it's a little bit easier to push out, which is important in the wintertime because it gets a little bit more solidified and harder to push out for either type. So having a slightly larger hole is really kind of nice. And next, I made an epic blunder, with regard to the UV solder mask. And basically my video serves as what you shouldn't do. I was really pressed for time that day, and I didn't have time to mask anything off, and I didn't think it would be a problem, but this 575 logic board, it really burns pretty easily with UV. And there's nothing electrically wrong with it. It just kind of looks unsightly and is embarrassing now that I've got this little burn mark, because I did it foolishly because I didn't mask it off. All said, use UV solder mask extremely sparingly. Just the thinnest little cover that you can make. And the reason why is because you'll need less UV light to cure it. And then when you are curing it, it would be a good idea to tape it off so that you don't potentially burn your board. And you might want to wear some UV cut eyeglasses or eyewear too, because if there's any kind of reflection, of that UV, you don't want it all going into your eyes. Next, I'd like to thank Stephen Arsenault. You've probably seen this cute little guy here on my shirt. He sent me this. He made these out of a PCB, this little Happy Mac here, and he sent me an extra one so I could send it off to Keikoba in Tokyo too. I wish to thank you, Stephen, for sending this to me. It's a cute little guy, and it has a really great strong magnet too. So it doesn't affix with a needle or pin on the back. It uses a magnet to stick on, which is very, very nice. You don't have to put holes through your clothes. So it's a wonderfully cute little guy. And I'm not sure if he's going to sell these or provide these, but I just wanted to mention that he did send it to me. So thank you, Stephen, for sending it off to me. I appreciate that. Next, before I close, I'd like to humbly thank Gail from Sandpoint, Idaho, for her very generous donation to this channel. Gail watched one or more of my iMac video card bake videos on how to resurrect the iMac's video card. These are for older iMacs from about the year 2008 through 2011, and they all have an inherent design defect. They go bad after a while. They get a blank screen, all black screen, all white screen, artifacts on the screen, your computer will lock up. And basically, it's very unconventional, but you can bake these cards in a conventional oven and get them to run again. There's a lot of naysayers out there who say it doesn't last very long, but I fumbled my first bake with a bad thermal paste job, and it only lasted 4 months. But my second bake got 2 years and 9 months, which is, it makes the bake worth it, basically. But Gail went through the process. She baked her video card. She got it back working again. And not only that, but she went the extra mile and swapped out her spinning hard drive for an SSD, and she even upgraded the RAM too. You can read her entire saga on the Tinker Different forum. I put a link for you in the text description below, and I've already thanked her privately for her donation to this channel, but I like to thank people publicly too, just to let everyone know that I'm excited when somebody does donate to this channel. So thank you once again, Gail, for your very kind donation. And I hope that your newly resurrected friend will give you many years of service from now on. And truly, he is a friend. I have my late 2009 iMac 2. He's still in service at home. He's our family workhorse, and he works fine for the purpose that he's used for, and we use him on a daily basis. And last but not least, stay tuned to this channel because we have more color classic videos coming. And in fact, the next video, I'm going to try to release it within the next few days. And I'm able to do that faster than normal because most of the filming on this new video was done by Kei Koba in Tokyo. And basically through the course of one of our conversations recently, he showed me something that he had made in the past. And I was just awestruck at his craftsmanship in making this. And I said, Kei, if I send you the required part, would you make another one and film it too so that everyone could see how you did this? And he very kindly agreed. Now, normally, Kei has a lot of experience being a handyman. He's into guitar repair and has a lot of tools for that. And he used those tools to create this. I'm not going to say what it is in this video, but basically he has experience doing these things. But still, he did it while filming, which it really makes it harder to do. You got your camera in the way. But he did this very kindly, and I want to showcase that to the world. So I'm going to be, adding in a little bit of commentary, but basically the primary video will be what he made, and it will show you how you could possibly make one as well. And in addition to that, of course, we're going to swap out the CPU with an FPU version. We're going to do overclocking. We're going to do a bunch of more things. And so stay tuned for those. If you like this video, please consider giving it a thumbs up. If you'd like to see more content like this, please subscribe. And once subscribed, be sure to click the bell icon to receive notifications when I come out with a new video. Thank you folks for watching to the end. I wish all of you a great week.